Assalamualaikum and hi semua. So in this video we are going to learn about chapter 3.1. Okay, but learning outcomes start from G until J. Okay, right. So by the end of this lesson, you should be able to define what is standard reduction potential or standard electrode potential, and then standard cell potential in not cell. However, for standard reduction potential and electrode potential, I already covered dekat part atas ni. Okay, alright. And then standard cell potential is something new lah. Okay, so the next one, you should be able to draw and explain standard hydrogen electrode, or you can call it as She. Okay, so kita nak tengok who is she. So nanti kita belajar lah. Okay, and then next one, by the end of the lesson, you should be able to construct standard reduction or electrode potential series by using She. Okay, so maksudnya She function dia adalah sebagai reference electrode. Okay, later on kita boleh dapat nilai E0. Contoh E0 for copper, E0 for zinc. Kita boleh dapat nilai-nilai E0 tu when we use She lah, bila kita compare dengan She. Okay, and then lastly, you should be able to use the standard reduction potential values to compare relative strength of oxidizing and reducing agent. Okay, so still remember, initially dekat part atas ni I already macam recap balik what is oxidation, what is reduction. Okay, so now you have to apply that knowledge to compare the relative strength of oxidizing and reducing agent. After that, you should be able to calculate E0 cell. Okay, so E0 cell or standard cell potential. And lastly, you should be able to predict the spontaneity of a redox reaction. Okay, so the other day we already covered yang atas ni. So kita akan start dengan cell potential lah. Okay, so what is cell potential? Cell potential is the difference in electrical potential between the anode and the cathode is called cell potential lah. Okay, so maksudnya perbezaan antara E0 anode dan E0 cathode itulah cell potential. Kiranya voltmeter kamu tu kan kita buat eksperimen. Kalau kamu dekat sekolah pun kita ada belajar, kita akan guna voltmeter sambungkan dengan kita punya electrode. Okay, so this voltmeter akan ada bacaan dia lah. Okay, so bacaan voltmeter ni kita panggil cell potential, kita panggil electromotive force, kita panggil cell voltage. Okay, so benda yang sama sahaja. Tapi bacaan voltmeter ni melambangkan apa? Bacaan voltmeter ni sebenarnya dia menunjukkan difference antara electrical potential between anode and cathode. So perbezaan electrical potential antara anode dan cathode, so hasil perbezaan tu adalah nilai voltmeter. Okay, alright. So next kita tengok we need to learn how to calculate standard cell potential E0 cell. Okay, so this one, yeah, okay, very important lah, because kita memang akan selalu guna this equation. Okay, so the electromotive force, okay, of a voltaic cell measured under standard condition. So this sentence explain to you what is standard cell potential. Okay, tadi standard cell potential tu ada kaitan dengan cell potential definition tadi lah. Cuma beza dia, this one dia ada the word standard. Okay, so when we have the word standard, dia ada E0 atas ni. And the word standard here to macam bagi tahu kita that the experiment is carried out at 25 degrees Celsius, the pressure is 1 atm and the concentration is 1 molar. Okay, alright. So electromotive force ni sama lah macam cell voltage, sama macam cell potential. Okay, alright. So how to calculate standard cell potential? By using this formula here. Okay, so formula ni penting, so you can highlight it. Okay, so you have to remember. Okay, so E0 cell equal to E0 cathode minus E0 anode. Okay, so E0 value here kita boleh dapat daripada table yang saya bagi dekat kamu tu lah, yang list E0 banyak-banyak tu, yang last page for chapter 3.1. Okay, so this is the formula to calculate standard cell potential. And then ada gambar rajah ni kan. Okay, so this gambar rajah adalah untuk bagi tahu kamu how to remember this formula adalah E0 cathode minus E0 anode. You can say kakak tolak adik, cathode tolak anode. So kakak tolak adik. So that's why ada gambar ni kat sini, bukan hiasan semata-mata. Okay, alright. So next kita dah ada example. Okay, very simple example. Okay, so in this question, dia bagi kita cell notation. Okay, we already learned this in the previous video. This is what we call cell notation. And from cell notation, dia juga bagi the value of E naught. Okay, so in exam, dia akan bagi value E naught macam ni lah. Okay, not like table yang dia bagi, table yang macam belakang yang saya cakap tu, dia tak bagi table tu, dia akan bagi nilai ni sahaja. Okay, so dekat sini tak ada soalan pula, but what this question nak adalah you have to calculate the standard cell potential. Okay, so nak calculate standard cell potential, macam biasalah, start with formula. Okay, jangan malas tulis formula. Okay, so now we know that we need to take value E naught for cathode minus E naught for anode. However, we don't know which one is anode, which one is cathode. Okay, but dia bagi kita cell notation. Okay, so from this cell notation, kita kena tengok lah mana anode, mana cathode. So macam mana nak tahu? Kan hari tu saya dah ajar, rule untuk tulis cell notation adalah ABC rule. Still remember? Okay, ABC rule here means we need to start writing anode punya cell dulu, and then double vertical arrow ni adalah salt bridge, and then next to the salt bridge adalah cathode. Sebab tu kena faham cell notation, so that you know how to interpret this cell notation, then you know lah which one anode, which one cathode. So in this case, cathode kita adalah copper, and then ini adalah anode. Alright. Another thing saya nak bagi tahu dekat sini, saya tahu kat sini kamu diberi value E naught, kamu diberi cell notation. So nak determine anode and cathode, you have to follow cell notation. Jangan tengok value E naught ni. Okay. So sebab dia bagi cell notation, tengok cell notation untuk determine anode and cathode. Kalau tak ada cell notation, tak ada equation lain, then only tengok value E naught to determine anode and cathode. Okay. Alright. So for this one, cathode kita dah tahu copper, so the value of copper is positive 0.34 volt, minus with zinc negative 0.76 volt. So E naught cell equal to positive 1.10 volt. Okay, so for voltmeter reading, calculation E naught cell kita 2 titik perpuluhan sahajalah. Okay. Alright, so kita dah dapat value E naught. Very simple. Okay, so another thing yang saya nak bagi tahu kamu, okay, ini cara saya ajar kamu untuk calculate E naught cell adalah by using this formula here, E naught cathode minus E naught anode. Tapi if you refer to lecturer lain punya notes, ataupun if you refer to reference book online ke, then you will see there is another formula other than this one, and that formula cara dia lain sikit daripada saya punya cara, tapi sama je lah, both you will get the same answer. Cuma for this one, this formula is easier lah, because you ada formula, you ada value E naught, then you just need to substitute the value E naught into this formula. Okay, you don't have to alter the value, tak perlu ubah apa-apa. Okay. Alright, so next one, standard hydrogen electrode or she. Okay, inilah yang saya cakap she tadi kan. So who is she? Okay, so she ni bukan orang. Okay, dia adalah satu jenis cell. Okay. Alright, so she half cell ni is made up of apa? Okay, so kita tengok. Made up of platinum electrode. Okay, platinum electrode, and then immersed in an aqueous solution of H+. The concentration of H+ adalah 1 molar, and bubble with hydrogen at pressure 1 atm and the temperature at 25 degrees Celsius. Okay, so as you can see, kita ada 1 molar, kita ada 1 atm, kita ada 25 degrees Celsius. So itu adalah condition at standard condition lah. So that's why ada the word standard depan ni. Okay, alright, and then hydrogen electrode. Okay, so for standard hydrogen electrode, gambar rajah dia macam bawah ni. So as you can see, dia ada this flask here. Okay, different from galvanic cell yang lain, sebab galvanic cell lain mana ada flask yang menutup sini kan. Okay, so this one dia ada flask ni sebab kita nak masukkan gas hydrogen. Okay, so hydrogen gas is bubble in dekat tepi ni. Okay, dia masuk dari sini. Okay, so kalaulah kita tak letak flask ni, then we can imagine lah the hydrogen gas takkan nak duduk dalam ni kan, dia akan terbang keluar lah. So in order to make sure the hydrogen pergi ke electrolyte tu. So we need to put this flask here. Okay, so bubblekan hydrogen pada pressure 1 atm. Okay, and then this electrode here, macam dia describe atas ni, is made up of platinum electrode. Okay, and then the solution here adalah H+. H+ here means acid lah. Okay, so dia tak spesifikkan what kind of acid, cuma dia cakap ini acid H+, and the concentration of the solution or electrolyte tu adalah 1 molar. Okay, so this is the setup for She. Okay, ini setup for She. Kalau soalan suruh kamu draw galvanic cell antara She dengan copper, so kamu kena draw She macam ni lah. Okay, alright, and then the electrode potential of She is defined as 0 volt. Okay, so ini yang special about She. Okay, kalau kamu perasan, kita ada banyak jenis electrode. Kita ada copper, kita ada zinc, kita ada aurum semua. Tapi kenapa kita tak discuss specifically about copper kan? Okay, so this one kita discuss specifically about standard hydrogen electrode half cell sahaja, disebabkan dia punya value electrode potential dia adalah 0. Okay, or if you want to look at this value here pun boleh. Okay, so dekat table ni, this is the value of E naught. Start from the most positive one to the most negative one. Okay, but tengah-tengah ni, this one yang pink color ni, okay, so ini adalah She lah. Okay, so this is She. Sebab apa? Sebab nilai dia 0 dan kamu tengok ini hydrogen dia. Okay, hydrogen gas, and then this is the acid. Okay, alright. Since dia adalah 0 volt, so kita usually akan guna She sebagai reference electrode. That's mean all the data yang dalam table tadi tu, okay, so back to this table, all this data actually can be obtained bila kamu pairkan kamu punya galvanic cell tu dengan She. Okay, so maksudnya macam dalam gambar rajah bawah ni lah. So if you letak She dekat sebelah, okay, and you letak another electrode yang kamu nak measure dia punya value E naught dekat sebelah, then your voltmeter reading ni kamu akan dapat. Lepas tu nanti kamu tahu dah your She tu 0, so kamu tolak, then you will get, tolak atau ikutlah, susun balik, and then you will get electrode yang satu lagi yang kamu nak cari tu. Okay, so that's why She is important. Okay, so kena ingat peranan dia. Okay, so next, using She to determine the electrode potential. Okay, so macam tadi saya cakap, She digunakan sebagai reference electrode untuk determine electrode potential yang lain. Okay, so kita tengok example. Standard electrode ataupun standard reduction potential of zinc half cell is measured by setting up the electrochemical cell as below. Okay, so as you can see in this electrochemical cell, She dekat sini on the right hand side, while zinc on the left hand side. Okay, so She dia boleh jadi anode, dia boleh jadi cathode, depend kepada keadaan lah. Okay, so in this case dia letak macam ni, and then dia punya bacaan voltmeter adalah 0.76 volt. Okay, and this voltmeter reading is called E naught cell. Okay, alright, so kita tengok lah what happen dalam electrochemical cell ni. So as you can see, anode berlakunya oxidation, NOx kan. Okay, so the zinc solid is oxidized to zinc ion, while for cathode, this hydrogen ion in the electrolyte is reduced to hydrogen gas. Okay, so that's why kamu nampak bubble-bubble ni lah. Okay, so this bubble produce apabila H+ ion ni direducekan. Okay, so now we already know which one is anode, which one cathode. Okay, so kalau kita nak cari E naught for zinc ni, dia macam ni lah. Kita ambil bacaan voltmeter kita dapat tu, which is 0.76. Okay, by using formula E naught cell equal to E naught cathode minus E naught anode. So cathode adalah She. Okay, so She kita tahu dia reference electrode, nilai dia adalah 0 volt. So that's why 0 over here. Okay, and then minus with anode punya E naught lah. So this is what we want to find. Okay, so E naught for zinc, then kita rearrange balik, bawa zinc pergi sini, this one bring to the right, and then you should get E naught for zinc is negative 0.76 volt. Okay, and this value E naught ni sama macam dalam table yang saya bagi dekat kamu. Okay, so kamu boleh tengok balik this table here. Okay, and then zinc. Yes, so the value of zinc is negative 0.76. Sama macam tadi. So, value-value ni kamu boleh dapat bila kamu set up your experiment macam yang dalam contoh ni. Okay, alright, so next kita tengok pula. Ini dia nak determine the reduction potential for copper. Okay, so dia pair up kan this She dengan copper electrode. Okay, so but this time kita punya She adalah anode. Okay, kita punya copper adalah cathode. Our inode cell is positive 0.34 volt. So kita masukkanlah dekat inode cell 0.34 volt, and then inode for copper is the one that we want to find, and then inode for hydrogen is 0 sebab She tadi. So tolak, tak ada apa, and then dapatlah inode copper equal to positive 0.34 volt. Okay, alright, so that's why She ni penting sebab dia boleh digunakan untuk cari electrode potential yang lain. Okay, so jom kita cuba try this one. Okay, so soalan kata calculate the standard cell potential for the following electrochemical cell. Okay, again dia bagi kita cell notation. Dia bagi kita value reduction potential for silver and reduction potential for cobalt. Okay, and then kita kena buat pengiraan. Okay, so since kita nak cari standard cell potential, that means we want to find inode cell lah. Alright, so inode cell yang kita nak cari, inode cathode kita yang mana? Okay, so kena determine cathode anode kan. This is cell notation. Okay, so dia ada ABC rule. Okay, so from here we can figure out silver adalah cathode. So the value inode for silver is 0.80 volt minus with cobalt punya adalah negative 0.28 volt. Okay, so over here minus, so dia akan jadi plus lah kan. So kita expect jawapan kita positif. Okay, so my answer is positive 1.08 volt. Okay, so that is inode cell. Done. Okay, so next try this two. But for try this two, cross out this cell notation. Okay, saya ganti dengan cell notation baru sebab sini kalau kamu perasan dua-dua reduction. Okay, so salah. So kita pakai this one. Okay, alright, so from this new cell notation, write down the half cell equation and overall redox equation for this reaction. Okay, so half cell equation here means equation for anode and equation for cathode lah. Okay, and then combine the two equation to form overall redox. Okay, so let us start with anode. Okay, so anode we know that from the cell notation yang sebelah kiri ni lah, ini adalah anode. Okay, so from Mg solid we produce Mg2 plus aqueous. Alright, so how to balance? Okay, so nak balance kita tambah 2 elektron je lah. Okay, so now our equation dah balance. Okay, so next kita pergi kepada cathode. Okay, for cathode berlakunya reduction. Okay, so cathode is this one lah. Copper 2 plus pergi jadi copper. Okay, so copper 2 plus aqueous plus 2E will produce copper solid. Okay, so kita dah dapat equation anode and cathode, then combine these two equation to form overall. Okay, so in order to combine, you have to check to make sure that the electron is on the opposite side. Okay, maksudnya this electron sebelah kanan arrow, and another equation punya electron di sebelah kiri arrow, so that you can cross them out. And then in order to cross them out, you have to make sure dia punya value sama, 2 elektron baru boleh cross out. Okay, so kita dah dapat dah overall kita. Okay, right, so done for A. Next is B. Okay, so B dia kata determine the species that act as oxidizing agent. So dalam ni anode berlakunya oxidation. Okay, cathode berlakunya reduction. So dia suruh kita cari yang mana adalah oxidizing agent. Okay, so kita recap, kita ingat balik. Oxidizing agent, that means diri dia sendiri mengalami reduction. Okay, sebab oxidizing agent dia oxidize benda lain, tapi diri dia sendiri terreduce. So reduction berlaku di mana? Reduction occur at cathode, right? Cat kan? Okay, so occur at cathode. Alright, so maksudnya dekat sini our oxidizing agent berada di cathode. Okay, so this is our cathode. So kita nak ambil mana? Copper 2 plus ke nak ambil copper solid. Okay, kita kata tadi dia mengalami reduction. So Cu2 plus ni yang terreduce. Okay, so your answer for oxidizing agent adalah Cu2 plus. Okay, so deduce anode and cathode for the reaction. Kita dah deduce dah. So ini cross out lah. Okay, tak perlu pun this equation. Question, sorry. And then next, lastly adalah calculate the E naught cell for the redox reaction. Okay, so standard cell potential. Okay, so kita nak cari E naught cell. Okay, so E naught cell equal to, okay, so cathode kita tadi adalah copper. Okay, so kita kena refer kepada SRP table kita sebab data tidak diberi dekat sini. Okay, so copper dekat sini positive 0.34. Okay, anode kita adalah magnesium. Okay, so magnesium adalah negative 2.37. Okay, so positive 2.71 volt. So that is our E naught cell. Okay, done for try these 2. Next, kita proceed to try these 3. A cell is set up between chlorine electrode and hydrogen electrode. Okay, so this is the cell notation. E naught cell also given. Okay, draw a diagram to show the rearrangement of apparatus and chemical use. Okay, so kita kena memang learning outcome, you should be able to draw galvanic cell. Okay, so ini diagram drawing dia. Okay, so kalau kamu perasan saya punya drawing, ini she, kita tahulah setup she, kita dah belajar tadi kan, ada flask. Okay, but this one pun ada flask sebab kalau ini tengoknya electrode dia platinum, dia punya chlorine ni gas. Okay, so memang kena ada this flask here kalau ada gas. Okay, and Cl- dia adalah electrolyte. Okay, as you can see, saya label juga kalau chlorine gas, the pressure is 1 atm, so mesti tulis pressure dia. Okay, Cl- equals concentration dia 1 molar pun mesti tulis. This is platinum solid, and ini pun sama, this is platinum solid. And for she, the electrolyte adalah H plus equals 1 molar. And then the gas in adalah hydrogen gas 1 atm. Okay, don't forget to draw your voltmeter. Okay, voltmeter saya buat arrow ke sini sebab saya tahu from this cell notation, ini adalah anode, she adalah anode. Okay, so and then ini adalah cathode, and kita belajar electron flow from anode to cathode. Okay, so kena that's why bacaan voltmeter kita akan ke kanan lah. Okay, and talking about electron, so kita kena label juga electron flow tu. Okay, alright, so done drawing. Okay, so next kita tengok B apa dia nak. Dia kata determine the standard reduction potential for chlorine. Okay, dia minta E naught for chlorine lah, and then discuss the chemical reaction occurring in the electrochemical cell. Okay, kalau discuss, that mean kita kena ada equation and a little bit of explanation lah. Okay, so next one adalah pengiraan tu. Determine the standard reduction potential for chlorine. Okay, so yang ini saya dah kira. Okay, so this is the formula to calculate standard reduction potential. And then we want to find yang chlorine punya reduction potential. So chlorine adalah cathode. Okay, so cathode minus anode. Anode kita adalah She, so 0. Okay, bacaan voltmeter yang dia bagi dekat kita atas ni, E naught cell, ini adalah E naught cell tu bacaan voltmeter. So masukkan dekat sini, then you should get your E naught for chlorine. Okay, so positive 1.36 volt. Okay, and then next one, the question asks you to discuss the chemical reaction occurring in the electrochemical cell. Okay, for this one, you have to make sure you write equation dekat anode and cathode, and then kena explain that equation. Okay, so for example dekat sini saya dah tulis, at anode, the hydrogen molecule release electron. Okay, so anode, hydrogen tu release electron. Sebab apa release? Kita tahulah anode tu kan berlakunya oxidation. Oxidation ciri-ciri dia kan release electron. Okay, and undergo oxidation to produce hydrogen ion. So basically this sentence kita explain balik je kita punya equation here. Hydrogen gas is oxidized to hydrogen ion. Okay, and then at cathode, chlorine molecule gain electron. Okay, sebab cathode berlakunya reduction. So reduction gain electron. And since they gain electron, dia akan form chloride ion. Okay, so Cl2 gas plus 2E dapat 2Cl minus aqueous. Okay, so kita settle try these 3.